Now, next, in trigonometric functions of any angles, we're going to talk about the Pythagorean identities. So we're going to begin with a circle. We have x and y up here, and some point P of x, y on the circle. We have that angle theta. If we were to draw a triangle right here, this triangle would have some radius r, or a hypotenuse r, which is the radius of the circle, some x value, and then some y value. Now, by the Pythagorean theorem, we have that x squared plus y squared is equal to r squared. But we also have, by definition of our trig functions, that cosine of theta is adjacent over hypotenuse, so x over r, and that sine of theta is equal to opposite over hypotenuse, y over r. So now, if I were to take sine squared of theta and I add it to cosine squared of theta, sine, if I use this value, sine is y over r, so sine squared of theta is y over r quantity squared. Cosine, if I use x over r, cosine squared becomes x over r quantity squared. So let me do a little simplifying. So we get y squared over r squared plus x squared over r squared. I'll combine this into one fraction and I'll write it as x squared plus y squared over r squared. I just prefer writing x before y. But addition, x plus y, or x squared plus y squared, is the same as y squared plus x squared. Now we have x squared plus y squared in our numerator. But from the Pythagorean theorem, we said x squared plus y squared was r squared. So this is r squared divided by r squared, which is 1. So this leads us to our Pythagorean identities. This first one states that sine squared of theta plus cosine squared of theta equals 1. Now, if we're to take this sine squared of theta plus cosine squared of theta equal 1, and we divided every term by cosine squared of theta, so now we can rewrite this. Sine squared over cosine squared is sine of theta over cosine theta quantity squared, plus this cosine squareds cancel, so that's just 1. And then we can rewrite the 1 over cosine squared of theta is 1 over cosine of theta quantity squared. Sine over cosine is tangent squared of theta plus 1 equals, and then 1 over cosine is secant squared, or secant of theta, and then quantity squared. So this leads us to our next Pythagorean identity, which states, and we're going to write 1 first. So 1 plus tangent squared of theta is equal to secant squared of theta. And then if we were to go back to our first one, sine squared of theta plus cosine squared of theta equals 1, and we divided everything this time by sine squared of theta, we would similarly arrive at our next Pythagorean identity, our third one, which states that 1 plus cotangent squared of theta is equal to cosecant squared of theta. These are our 3 Pythagorean identities. Our last topic are even and odd trigonometric properties. Now we have that cosine and secant are even, in the sense, if you recall from some of your algebra classes, the definition of an even function is that if your input is negative, the function remains unchanged. So cosine of negative theta is just going to be cosine of theta, and similarly, secant of negative theta is the same as secant of theta. But we also have that the sine, cosecant, tangent, and cotangent functions are odd. And so we get sine of negative theta, an odd function. If you put a negative in for your input, then you get a negative for your output. So this is sine of negative theta is negative sine of theta. Tangent of negative theta is negative tangent of positive theta. Cosecant of negative theta is negative cosecant of theta, and then cotangent of negative theta is negative cotangent of theta. So to prove this, what we can do is we will consider a point on the unit circle. Let's just say some angle theta, and that point P of x, y. This is a unit circle. So x and y is a value of 1. This is a value of 1 right here. And if we were to go down at a negative theta, we would go in the opposite direction to some point Q. And this Q is going to be at the point x comma negative y. By the definition of our trig functions on a unit circle, we have that sine of theta is the y value, so it's just y. And we have that sine of negative theta, so we're going down here for this angle, is also the y value, which is, in this case, negative y. And we also have cosine of theta is x, and then cosine of negative theta, well, it's coming down here. The value for that is just x. And so, combining these things, we have sine of negative theta is negative y. And if I multiplied this top equation by negative on both sides, we would get that negative y is negative sine of theta. So that's how we get negative sine of theta, proving that sine is negative. And then to prove that, sine is odd. To prove that cosine, well, both of these functions are equal to x. And so we get cosine of negative theta is x, which is cosine of theta. Therefore, we get that cosine is even. Now, to prove tangent, we're going to have to use some identities. Tangent of negative theta, well, tangent is sine of negative theta over cosine of negative theta. And then we knew that sine of negative theta, since it's odd, negative sine of theta, then cosine of negative theta, since it's even, is just cosine of theta. This is going to be negative sine over cosine of, that's tangent of theta. So this is tangent of negative theta equals negative tangent of theta, and therefore we have that it is odd. It's an odd function. For cosecant, secant, and cotangent, we would use the reciprocal properties. I'm not going to go ahead and prove them, but we know that cosecant of theta is negative 1 over, or excuse me, is just 1 over sine of theta. And so the same way that we would prove that, we can do this. Secant is 1 over cosine, cotangent is 1 over tangent. So let's do an example. We can use the even and odd properties of trig functions to find the exact value of cosecant of negative 30 degrees. Now we know cosecant is an odd function, and therefore this would be equal to negative of cosecant of positive 30. Now you can refer to your trig table or whatever you would need to find out what cosecant of 30 is, and you would get cosecant of 30 is 2. So cosecant of negative 30, because this is odd, is negative 2. One more example, and let's say if cosine of theta is 0.4, determine cosine of negative theta. Well, since cosine is even, cosine of negative theta is going to be cosine of regular theta. And we know cosine of theta is 0.4, so cosine of negative theta is just 0.4.